Hi everyone, and welcome to this video. So we're going to continue on this CSCA exam. We are at the question 31. The last question we've talked about last video was the 30. It was to see the correct answer. So for 31 here we have, in a uniform magnetic field, a particle with charge Q is injected perpendicularly into the field with velocity v. If the magnetic field strength is B, we have here V, we have here B, the magnitude of Lorentz force acting the particle is. Which one of these four is correct one? As we know, we need to just like to state what is the formula of a magnetic force, and we do know if there is a charge, a Q is moving with a certain velocity v inside a magnetic field, so it's experiencing what we call a magnetic force. The magnetic force is expressed as a Q v velocity cross the magnetic field. So this is the Q v times b times the sine of the theta, with the theta is just like the angle between the direction of v and b. So this is an angle. What we have here is that charge is injected perpendicularly into the field. That means the angle here is only 90 degrees. So we can write that the F would be QVB times the sine of 90 degree. The sine of 90 degree, as all we know, is equal to 1. Finally, we can conclude that the F would be the QVB. This is simply the answer to this question. So the A would be chosen as the correct one. Let's move now to the question 32. Here we do have for three resistors with identical, we have the three are identical resistance values. If R1 is the total resistance when they all are connected in parallel, okay, and R2 when all are connected in series, then the ratio R1 for the R2 is it 1 to 3, 1 to 9, 3 to 1, or 3 to or 9 to 1. Let's just like analyze this question here. We see that the R1 is the equivalent resistance for we have here R1, the total resistance for parallel. The R2 is equivalent to the series. What do we know? If a certain number of resistors that are identical, we need to specify that if they are identical, so the equivalent resistance would be a certain R1, just like here, would be equal to the value of one of them divided by the number of those resistors, which means for our case here R1 would be R divided by 3, because we have 3 resistors, the number of resistors. This is the value of R1. What about the R2? The R2 is the equivalent resistance for the 3 if they are connected in series. In series, for sure, we do know that the equivalent resistance is adding up. So if we have a certain number n of resistors that are identical, we just can multiply that number by the value of one of them. In our case, again, here we have R2 is 3 R's. What is the ratio now? R1 to the R2. We can only divide R1 by R2, which means it's equal to R divided by 3 over 3 R's. This is giving mathematically the R divided by 3 times 3, it's 9 R's. We can get rid of the R here. This is giving 1 over 9. That means R1 to R2 as a ratio is 1 to 9. So do we have this option here? We do have the B 1 to 9. Okay. For the 33 here, which of the following statements is false? Again, which one is false? Which one is not correct? About the Ampere's rule, right-hand rule. So, to determine the direction of the magnetic field of a straight current, I mean. For this, for the Ampere's right-hand rule, if we do remember the last video, we've talked about this situation here. The relation between the magnetic field and the current in a straight wire, just like with the current inside of it. If there is the currents, and the right-hand rule could be used to determine the direction of this magnetic field. So the thumb is pointing to the direction of the current, and the curling fingers would motion or demonstrates what is the direction of this magnetic field. So here we have okay. Here we have A is correct. To determine the direction of the magnetic field of a straight current, that's correct, because as we said in the previous video or in the previous image here, we can determine the direction of the magnetic field just like applying the right-hand rule. So the A is correct. For B, to determine the direction of the magnetic field of the ring current, the same for a certain ring. If we're curling our fingers like that, the thumb will just like point to the direction of the field or the magnetic field. That means the B is correct as well. To determine the direction of the magnetic field of a solenoid, the same. If we have a solenoid and putting our hands as the four fingers are pointing to the turns, so the thumb will point to the north pole of this solenoid. That means the thumb will point to that direction. Okay, so for C is correct as well. To determine the direction of force on a moving charge in a magnetic field. So we need to pay attention here. For the D, determining the direction of force, we need to use what we call the right-hand palm rule or the Fleming left hand. So for here, the thumb is representing the current and the four fingers representing the magnetic field. Finally, the palm will just like face the force out of the page in our case here. So for the force, we need to use what we call the right hand palm rule or the Fleming left hand, one of them, but not the Ampere's rule in general here. So for D, this is the false one and the one that we need to choose as a correct answer for the 33 question. Let's move now to the 34. Here we have for an electric motor with rated voltage U and coil resistance R, the output power under normal operating condition is it UI or I square R, or UI minus I square R, or UI plus I square R? So for an electric motor what is the utility of an electric motor? There is a certain power that get in to this motor, and there is a certain power that get out of the motor. But because none of the motors in the world is 100 efficient, there would be what we call a loss, P lost. Okay, that means the total power getting into the motor just like to function, there would be a certain power that would be converted to a mechanical motion, and there would be a loss as a heat because the motor is composed of a coil with a resistance R. So we can write mathematically the Pn will be equal to P loss plus the P out. So the question is about the P out as a kinetic power here. That would be the Pn minus the P loss. So for the Pn, for sure, it's just like what is the voltage and the current flowing through the motor. The P loss, as Joule's law says, we have the I square times the resistance. This is the total power loss as heat here. Finally, we can write that the Pn would be equal to the Ui, the Pn, subtracting the power lost as heat R. So finally, we can write that as a final answer. Which one of those representing our answer is the C? Okay, so C is the choice here. For the 35 here, the final question for this video, we have which of the following statements is true about the electromagnetic waves? So we are moving into electromagnetic waves here. And what is the correct one from this list? We have electromagnetic waves need a medium to propagate. This is actually not correct, because what makes the big difference between electromagnetic waves and mechanical waves is that the electromagnetic waves doesn't require any medium to propagate. Just like light coming from the sun, it's propagating through the vacuum, through the space, so in order to reach the earth. So between the earth and the sun there is nothing, as the light is an electromagnetic wave. So A is not the correct one. For B, we have electromagnetic waves are transverse waves. This is actually the true answer. We have here the representation of the magnetic waves. A magnetic wave is composed from two fields. The electric field that's moving sinusoidally, and the deformation is perpendicular to the direction of propagation, and the magnetic field, and they are perpendicular to each other as well. So the angle is 90 degrees between the propagation and the displacement of this amplitude of each one. That's what makes it as a transverse wave. This is actually the definition. For C, the wavelength in infrared is shorter than that of ultraviolet. This is incorrect, and the opposite is what is correct actually. Electromagnetic wave cannot interfere and diffract. This actually not correct, but it can interfere and diffract if we use what we call the Young's slit. Okay, so there is a phenomenon that we call interference and diffraction. This is it for this video. Hopefully that makes a lot of understanding for you. See you in the next video.